Hi everyone, welcome back to the EBI Seminar Series. Continuing our theme, Biomass to Breakthrough, today we're joined by Professor Alexander Goldberg from the School of Mechanical Engineering at Tel Aviv University to talk about his work on seaweed-based biorefineries and their role in the growing blue economy. In this session, we'll learn how seaweed cultivation and processing can be used to produce renewable fuels, bioplastics, and other high-value products, and what engineering and sustainability challenges come with scaling these systems. Thank you for watching and enjoy. Hi, Alexander. How are you doing today?
I'm good, thank you.
Yeah, that's great to hear. So to start off, culture and the blue economy are a couple terms that come up a lot in your research, and they're becoming major topics in sustainable development. Why do you think now is the time to focus on these areas, and how would you define them in the context of your research?
So I think that currently, as always, it's a good opportunity to get into this and start this. But as we see, seaweeds, this is the silviculture, are still mainly underexplored biomass sources. So if you go and you see in the sea, you will not see big seaweed farms. And the seas are big and there are a lot of nutrients and light there. So this means that we still have huge opportunity to use the sea fields to grow the new types of the biomass. And once we have the biomass, it definitely can be used as a part of the bioeconomy. So as we define sea agriculture is something where we use sea to grow things, and this can be seaweeds, can be fish. People grow many types of things inside in the oceans, and also bioeconomy. It's much broader than seaweed. So seaweed is a part of it. So they are mainly primary producers, but we also can think about herbivorous fish and other creatures people use. Of course, we need to grow them sustainably and think what gets in the system, what gets out, and so forth. But if we look all together of this, I think that this is a huge and underexplored opportunity which is there. And importantly, it can uh, take care of part of the damages we've done to the agricultural land. Yes, because the humanity will need biomass, and the question is where this biomass will come from, whether with the further deforestation, so you will clean more lands to grow crops, or probably we can just save the forest and try to use the seas to produce the biomass.
And what first inspired your interest in seaweed and macroalgal biorefineries? Was there a specific moment or challenge that led you to explore this emerging field?
Yeah, so I can tell it was 2006. We were dining with my friend who's a physicist scientist, and we were thinking about and eating krill, I think. And the question rose whether it is a sustainable way to get protein. And the most widely used plant protein is soy, and then it was sparked the idea whether soy is a sustainable source. And obviously, it is not because you need to clean agricultural land to grow it. And this is how I came into the macroalgae as the source of protein. So I'm stuck with this idea already for a long time.
With that in mind, what do you see as the most promising technological or engineering breakthroughs needed to make seaweed cultivation and processing both efficient and economically viable?
So I think we need actual mechanical systems which will allow large-scale seaweed cultivation. Because currently this is a huge challenge. I can give you an example. Our experimental farm in Tel Aviv University just was blown with a wave, which was 14-meter wave, and we found it many kilometers out of the mooring space. So we need to really find tools to explore the ocean in terms of finding the right locations and finding the right technology to grow seaweeds in those locations, and also with the ability to predict the weather. Because if we knew that there is going to be a storm, probably we should, think how either to wrap the farm or put it underwater and do something with that. So working in the sea is not easy and requires a lot of knowledge, I think, that we still do not have. Starting from weather predictions towards technologies how to address with those changes in the weather.
As we move toward industrial adoption, what developments are driving the commercialization of macroalgal products and what barriers still remain?
So I think that availability of the biomass, but it very depends on the application because macroalgae is a very broad group of plants. And if you ask me today about agricultural plants, there is no single answer because each plant has its own application. Like rice is different from lettuce, and it's different from apples. And you can think about macroalgae in the same way because we have more than 1,000 species and they're all very, very different. And I think at the end, each of those species will find its own application with its specific challenges. So my group will look more into the food and biomaterials application of seaweeds. Again, food can be different. If we look into the hydrocolloids, the polymers which make gels, and there are multiple groups, or we'll look into nutrition, for example, protein supply. This is an absolutely different application. You use very specific species, and the challenges are different because you need to find the right application for those proteins, which are different from other proteins we currently use today. Same in biomaterials. Biomaterials can be used for cloths or they can use for tissue engineering. So I just have a great PhD student. She finished her PhD on using seaweed-derived cellulose for tissue engineering, and she showed that two green seaweeds coming from different species like ulva and cladophora have very different cellulose with very different properties in which you can explore for wound healing, but they're not the same. I mean, they look green, but they smell the same, but they're not the same in terms of their functional final properties.
So, alongside the economic side, there is the environmental aspect. What are some of the environmental trade-offs or benefits of large-scale seaweed farming, particularly in terms of marine ecosystems and carbon sequestration?
Yeah, now imagine that you cover the whole sea with seaweed. So I guess nobody will want it. Yeah, people want recreation. They come to the beaches to swim and to see nice views, and they don't want to smell seaweeds. You can look what happens today in Caribbean when there is a lot of seaweeds coming. A great sargassum belt, which just destroys the beaches in Miami and Caribbean. So these are very clear environmental issues because the seaweeds rot and they can, close the beaches, they can close and damage marine transportation. And for ecosystems, they can shadow. Like imagine you have a huge, huge, huge field, hundreds of kilometers of seaweeds, so they will shadow the light for all the organisms which I used to live there, microalgae and others which feed on them, on fish and so forth. So it's very nice to describe this as the seaweed fields on which all the fish and other coexist, but that's natural fields. We're talking about commercial farms, and commercial farms might damage the natural ecosystem because you explore single culture, monoculture, multiculture, and so forth, but that's a lot of activities which were not in the sea before. And exploring the ways these big farms can affect the environment should be done ahead of time. And as an example, we all know what happens with the fish farms. Because once fish was put into the ocean at the beginning, everybody thought it will be fine. Now, if you go and you look what happens on the bottom of these farms, they are all damaged and destroyed because of feeding, which was not correct. Because people just poured and poured. Still now, the feed which fish don't eat, but this feed goes down and then rots on the bottom.
So, your book, Macroalgal Biorefineries for the Blue Economy, explores a few potential applications. Which seaweed-derived product do you think holds the most promise for near-term market adoption?
So we explored certain applications which are not on the market right now because few applications of seaweed polymers such as carrageenan and agarose are within our economy for 50 years. So we all use them all the time in bakery, in desserts, in every gel forming agent, in ice cream, in all many milk products have them. So seaweeds today, it's a huge market with more than 30 million tons of seaweeds produced for the extraction of hydrocolloids. Now, what happens with the leftover? Not very clear. So how they are used and where they're thrown or not thrown and what is done with these. And this is a big market with it's almost 11 billion dollars today. So now what will be next? And this is a big challenge. So I think that we need really to explore multiple applications. Myself, I think that seaweeds can be a great source of industrial protein. So my lab spinned off the startup in this area called Genesee, which developed the industrial process for seaweed protein production. But also there, the challenge is to find right applications because originally the proteins have very specific functions which fit to certain applications. So they're probably good to pasta, bread, crackers, some others, but they will not replace milk at this point. So this is what we learn already in the industrial way. Now, how to make pasta with the seaweed protein and make people eat it as a protein source, it's a challenge. So we need to address this. But I mean, that's in terms of my views and in terms of food. But I know people explore and seaweeds in many different applications, from packaging and materials and so forth. And each one of them has its own challenges which need to be addressed.
How do you envision the future of the bioeconomy, and what role do you see marine biomass, especially seaweed, playing in creating more circular ocean-based industries?
So I think that seaweed ingredients need to find the applications, because once we are able to find major applications, not small ones, but big ones. That's why we went after food, or it can be energy, it can be materials. So once the big applications are there, big applications in terms of volumes, then it will drive all the seaweed bioeconomy down. Yes, because if you find some niche market like biostimulants, which is fine, but it's like very small and it's not very clear whether it is good, it's not good, and how good and to whom it's good. So it will be a nice niche product. So it's a boutique products. We talk about major things. So for example, if we go back to the idea of starch. So my group also had a very good postdoc, Meganauts, who was working on starch from seaweed. So starch is a commodity. Yeah, it's a cheap commodity, but we made starch, white starch, looks like rice starch from offshore grown seaweed. Now imagine this becomes a reality. So this over drives immediately the demand for seaweed, and you will see people farming seaweed for the starch of protein and other things. So I think that as the community, we should focus on commodities coming from seaweeds, not niche products, and try to solve the issue of adoption, volume, costs, and so forth.
And finally, what are the biggest challenges currently facing mass seaweed cultivation, and how can academia, industry, and government really work together to overcome these challenges?
So I think the major problem is in the adoption, because today what seaweeds can solve in most of cases has problems. Those problems have a solution, which are not environmental. Yes. So for example, protein. Now we have more than 20 types of plant proteins today. So why should they use seaweed protein? The only environmental claim from what we've seen the last 5 years is not sufficient. Yes. Even though if you come and you say that, we have much more environmentally friendly protein, it doesn't need any arable land, no fresh water for its production, we currently are not able to persuade the large-scale manufacturers of plant proteins that this is enough. Yes, they want to see regulation, they want to see the supply chain, the volumes, and so forth. And this is like a chicken in the end, because if there is no demand, like farmers will not grow seaweed. So this is the challenge, and I think that there should be solutions based on, first of all, adoption. So the industry and all the shareholders need to decide that they want to go on for specific applications and show successful case studies. Then we can bring the government and all the rest. But my opinion is that we need to bring large food or material companies into this, and together with them decide which of the applications they see is the most appealing one. Can be any of these, but there should be something which replaces existing materials or provides a new product. So yeah, that's the challenge. That the adoption of seaweed-derived products in the large scale as commodities. I think this is very challenging.
That was all the questions from us. Thank you, Alexander, for joining us today and sharing your insights on seaweed and the blue economy. It's been a great conversation, and we wish you a great rest of your day.
Thank you, Melanie.
Thank you for tuning in to the Biomass to Breakthrough Seminar Series, where we explore how renewable feedstocks can be transformed into fuels, plastics, and other sustainable products. If you enjoyed the session, be sure to like and subscribe for more content on biomass conversion and the clean energy transition. You can also catch up on previous talks or follow us on social media, all linked in the description below. Thanks for watching, and we'll see you next time.